In this tutorial, I am going to discuss how to convert an infix expression to postfix, and similarly I will discuss how to convert an infix to prefix expression using the stack data structure. So let us see the definition of a stack. A stack is an ordered collection of homogeneous data elements where insertion and deletion take place at one end only. Like an array and linked list, stack is also a linear data structure, but the only difference is that in case of array and linked list, insertion and deletion operation can take place at any position. That means we can delete or insert element from an array from the middle also, from the end also, from the beginning also, or from any specific position we can do this operation. Similarly, we can do insertion and deletion in a linked list in some specific positions, in the beginning also, in the end also, in the middle also. But this sort of functions are not allowed in a stack. In a stack we can perform the insertion and deletion operation only in a single end. Moreover, the stack can be represented using an array, or we can represent stack using a linked list data structure. So the main operations which are performed in a stack are push and pop functions. So the push operation is used to insert a particular element to a stack, and pop operation is performed to remove an item from a stack. So to perform these two operations, we'll have to use a variable or a pointer known as the top pointer of the stack. So other two functions or operations I have mentioned here. So one is empty. So this function is used to check whether the stack is empty or not. And another function I have mentioned here, it is the pick. So this pick function is going to return you the top element of the stack. So now I will go to a particular application of stack for converting arithmetic expression into different forms. Normally the arithmetic expression are written in infix format. An infix expression is an expression written with the binary operators in between the operands. So operand, then operator, then operand. So operand can be some variables or it can be some values. An operator can be, say, binary operator can be addition, subtraction, multiplication, modulus. This is division, and this is exponential. So for example, say a plus b can be a infix expression. Then the next expression is known as prefix expression, and also popularly it is known as the Polish notation, and this expression was designed or invented in around 1942 itself. So in a prefix expression, operator always comes before the operand. Okay, then we are having another expression that is known as the postfix expression, which is also known as the reverse Polish notation. So in postfix expression, the operator will come after the operands. For example, the infix expression is, say, 5 plus 4 is within the braces into 6 plus 3, and it is the infix. Then by using some methods or some steps, we can convert this infix to a postfix notation. So here you can see 5 plus 4 is 5, 4, then addition operator. So after doing this operation again, this is say A, say it is star, say it is B. So A, B, star, right? So 5, 4 plus 6, then star. Then again it will be considered as one element, then plus 3, it will be 3 plus. So that can be one way to convert to postfix. So let us formally check the different steps for performing the conversion part of infix to postfix using the stack. So before going to that conversion, we need some highlight of the operator precedence and association rule related with the operators. So presently we are dealing with the 6 binary operators. So exponential always have the high precedence. Say here I am giving the value, say 1 is the high, then 2 is the mid, and 3 is the low. So 2, the precedence value 2 is for the 3 operators, multiplication, division, and modulus. So they have the same precedence and their association is from left to right. And for the exponential, the association is from right to left. Say for example, say 3, then 2, say exponential. So it means that we'll have to return 3 square, because the expression will be, or the association for exponential is from right to left. So similarly we are having for addition and subtraction, it is from left to right. So after getting the idea of the operator precedence and association, now let us see the steps to convert the infix to a postfix notation. So let x is an arithmetic expression written in infix notation. Then by using a simple algorithm, we can find out the equivalent postfix expression, say y. So from the given expression x, we'll have to read one by one element from left to right, and we'll repeat the different steps from say 2 to 5 for each element of x until the stack is empty, or the expression which we are presently reading is reached the end of the expression. So if the symbol or the character which presently the program is reading is an operand, then we'll have to add it simply to the expression y, or in the postfix string. Okay, suppose if the character which the program is reading is a left parenthesis, then we'll have to push it into the stack because it is not a operand. So if operand will arise, then simply we'll add it to the expression, postfix expression. If operator will come or say parenthesis, then simply we'll have to push it into the stack. But when operator arises, we'll have to check these 3 conditions. So if the operator has higher precedence, which the presently the program is reading, then the top of the stack or the top element of the stack, then we can simply push it into the stack. If the incoming operator has equal precedence with the top of the stack, then we'll have to use the association rule. If the association is from left to right, then pop the element and print the top of the stack, or we can add it into the postfix string, and we'll have to push the incoming operator into the stack. If the association is from right to left, then push the incoming operator into the stack. So simply we'll have to push the incoming operator into the stack if the association is from right to left. Then another condition we can check is like if the incoming operator has lower precedence, then what will happen? So if the incoming operator has lower precedence, then the symbol on the top of the stack pop the stack, and we'll have to add this into the expression. Then we can test the incoming operator with the new top element of the stack. So if the incoming element is the right parenthesis, then repeatedly we'll have to pop out the element from the stack until the left parenthesis will encounter. So these are the comparisons we'll have to perform, and these things will carry forward until the expression will reach the end. So the steps to convert infix to prefix. So for converting an infix to prefix, we'll have to take the help of this algorithm. But before taking the help of this infix to postfix, we'll have to first input the infix expression, then reverse the expression. So this is a very important step. So after reversing the expression, we'll have to apply our previous algorithm order steps of infix to postfix conversion. Then after converting the expression to postfix, then again we'll have to reverse it back. And after reversing, whatever the expression you will get, that will be in the format of prefix notation. Okay, so I think the idea is clear. Now let us look for some examples, then I think it will be clear. So let us take an example of an infix expression which we are going to convert to postfix notation. So we'll have to read one by one element or one by one character from this expression until we will not reach the end of the expression. So initially the program will read this opening parenthesis. So current symbol is opening parenthesis, so it is not an operand, so we'll have to push it into the stack. So in this table I am considering 4 columns. One is the current symbol, another is stack, one is postfix, one is the description. Okay, so the next character the program will read is a operand, so it is not a operator, so it will be added into the postfix string, or from our algorithm point of view, it will be added into the, this is my y actually, so here I am adding. Then the next character the program will read is multiplication, so it is operator, so it will be added into the stack, or will push into the stack. Then the next is b, so b is a operand, so we'll have to push it, we'll have to add it into the postfix string. Then the next symbol is a closing braces. So what we'll have to do, so we'll have to pop out all the elements until the left parenthesis will read, right? So here is my opening, here is my closing parenthesis, so in between this opening and closing we are having the multiplication, so we'll have to pop it out, so it will be added into the postfix string, so AB star. Now the stack is empty. The next symbol is plus, so plus will be pushed into the stack and my postfix expression in AB star. The next symbol is C, so C is a operand, so it will be added into the postfix expression. And finally there is no element left, so we can pop out the element from the stack, and the final element which will be pop out will be addition, and it will be added into the postfix expression. So this is the final result. Okay, now let us check another example. So A star B exponential C plus D. So A will be read, so it is an operand, it will be added into the postfix string. Stack is initially empty. Now the program will read multiplication, it is a operator, it will be pushed into the stack. Then the next symbol is B, so B is a operand, it is added here. Next symbol is exponential. So now the current symbol is exponential, and the top element of the stack is multiplication. Now the precedence of exponential is higher than the multiplication. So compare this exponential with the top element. Top element here it is multiplication. As exponential has high precedence, so exponential will be pushed into the stack. So it is pushed. Okay. Next is C. So C is a operand, so it will be add here. Next is plus. So whether plus will be added into the stack directly. So before adding, so we'll have to make the comparison, right? So the plus will be compared with this exponential. So plus has lower precedence, so it cannot be directly pushed, so we'll have to pop it out the exponential. Okay. Then again plus will be compared with this multiplication. Multiplication again has higher precedence, so multiplication will be pop out, so it will be added into the expression. Then only we can push the plus operator here. So presently the postfix string will be ABC, then exponential, then multiplication. So the description is written here. Then the next is D. So D simply will be added here, right? Then there is no element left, so simply we can pop out the stack and the last element from the stack, that means the top element will be added into my expression. So this is the final result. Okay. So I think the idea is clear now. Let us check the example for infix to prefix. So this is the example which I have taken. So it is in the infix a plus b exponential c, and multiplication d plus e. Okay. So first we will have to reverse this infix expression. So after reversing, the expression will look like this. Then we'll have to make this opening will be like closing and closing will be like opening. So we'll have to do this reverse also. So my expression, the reverse expression will look like this, right? Then this reverse expression, what we'll have to do, we'll have to convert it to postfix format, is not it? So we'll have to convert this expression to postfix. So let us check in the next slide. Actually I have shown. So this is my reverse expression. So the similar steps we'll have to perform here for converting to postfix. So E will be added into the postfix. Stack is empty. Now operator is plus, so it will be added into the stack. Then D is the operand, it is added into the postfix. Then multiplication. So multiplication has higher precedence than plus, so we can push it. Then opening braces, so opening braces will be added. Then C will be added in postfix. Then exponential again will be added into the stack. Then B will add it into the postfix. Then plus, right? So whether plus can be added directly into the stack? No, we cannot, because the top element here, it is exponential, has higher precedence, so plus cannot sit over the higher precedence operator. So we'll have to pop out the exponential and it will be added into the postfix string. Then the next element here, it is A, so A will be added here. Then the program will read the closing braces. So when the closing braces will come, so we'll have to pop out the plus first. So plus will be added. Then the next top element will be this multiplication. Then the next top element will be plus, so it will be added. And finally the stack is empty, and this is the expression. Okay, the postfix expression. Now what we'll have to do, again I'm going back to the previous slide. So this is the expression which we have got, the postfix. So as per the steps for infix to prefix, again we'll have to reverse it back. So after reversing, whatever the expression I'm getting here, that is in the prefix notation. So this is the final result. So I think the idea is clear how to convert infix to postfix and infix to prefix notation. Now let us check the program for infix to postfix. So here I have designed this program in C++. So one class is designed here. So the class name is say into post. So one array is used here or array or a string, because we can use symbols also, we can use characters also, so that's why it is a character string. So the two operation push and pop, and another function here I have used is the precedence, and this is my in post function. It is for the conversion part. So the push function, then pop, then this is the precedence, okay, and this is the small steps. That means we'll have to read one by one character until it will not reach null. So if it is a opening braces, we'll have to simply push, and here I am using alphanumeric. So if it is closing, then we'll have to pop it out. So, and here the precedence is used, while the top element precedence is higher than this, then we are popping out. So all these operations are shown here. Okay, so let us run this program with one simple expression so that you can get the idea. Say I'm just writing a plus b plus a c. So what should be the output? AB plus C plus. Okay, so this is the postfix expression. So I think the idea is clear. So the program is presently written in C++ using the class concept. So from your end, if possible, try to design it in some other languages also, in C also, or say in Python also. So in different ways we can design these programs. So thank you very much.